Today we're going to look at an Algebra 2 class on solving rational equations. The easiest type of rational equation to solve is one which is a proportion. We solve it by finding cross products or cross multiplying. So let's take a look at an example for that. And whenever we have fractions, we also need to make sure that we're not dividing by zero. So that brings up the situation where we need to check for extraneous solutions. Before I solve, I'm actually going to look at limitations for the values that could be our solution for x. In our fraction 7 divided by x minus 2, the x minus 2 can't be 0 because we can't divide by 0. So we have the restriction that x can't equal 2. In the fraction 11 divided by 2x minus 10, again, we have the restriction that the denominator can't be 0, so 2x minus 10 can't be 0, which means 2x can't be 10 or x cannot equal 5. So when I find my solutions to this rational equation, I need to check to make sure that my solution is not one of my excluded values for x. So let's go ahead and solve this equation by doing cross products. In cross products, we multiply across the equal sign, numerator times the opposite denominator, and denominator times the opposite numerator. So as we do that, we take 7 times the quantity 2x minus 10 has to equal 11 times the quantity x minus 2. Distributing, we get 14x minus 70 equals 11x minus 22. Now we have just a simple linear equation that needs to be solved. We're going to subtract 11x from both sides to get 3x minus 70 equals negative 22. And then we're going to add 70 to both sides, so we get 3x equals 48. Finally, dividing both sides by 3, we get x equals 16. We take our solution and we check it against our restricted values for x. It's not one of those, so x equals 16 is our solution to that rational equation. Now, when the equation has more than one term on each side, we need to find the least common denominator, and we actually need to combine fractions. So we need to remember how to add rational expressions. As we get started on here, we're going to start by actually looking at the restrictions, the values that we can't have for x. Remember, our denominator can't equal 0, so x minus 5 can't equal 0, which means x can't equal 5. And in our other fraction, dividing by x is in our denominator, so our x cannot equal to 0. Those are two restrictions that cannot be solutions to this rational equation. Next, we're going to find our least common denominator. In our least common denominator, we need to have one factor of each of our denominators in our least common denominator. In this case, our denominators are 1, x minus 5, and x. They have no common factors, so the least common denominator is just the product of the denominators. We're going to leave that in factored form because it's going to make it easier for us as we move forward. So each one of our fractions here needs to be written with the common denominator of x times x minus 5. Our first fraction is the whole number 1, which is really 1 divided by 1, and it doesn't have either of those factors, so we need to multiply both numerator and denominator of 1 by x times x minus 5. So x times x minus 5 in our denominator to get our common denominator, and x times x minus 5 in our numerator, so we are multiplying by 1. In our second fraction, it has the factor x minus 5, so it needs the factor x, so let's multiply numerator and denominator by x to get with the common denominator. And on our other side of the equal sign, we have 3 divided by x. We have the factor x, it needs the factor x minus 5 to both the denominator and the numerator. Now, once I have fractions with a common denominator, here's the best part of it. When I add fractions with a common denominator, the only thing that I add together is the numerator. And so the equation that we're going to be looking at is only the numerator has to add up. The denominators already match, so all we need to do is make sure that our numerators match. So I need x times x minus 5 minus 8x to equal 3 times x minus 5. Making sure that when I subtract my numerators on the left, it's the same as the numerator on the right. Okay, so now let's go ahead and solve this equation. We need to distribute the x. We get x squared minus 5x, and then minus 8x. And then we have on the right side of the equation, 3x minus 15. It's a quadratic equation, so we need to get one side equal to 0. Let's go ahead before we do that and combine like terms on the left. We have x squared minus 13x equal to our right side of 3x minus 15. Now subtracting 3x from both sides, subtracting 3x from both sides and adding 15 to get one side equal to 0. So we have x squared minus 16x plus 15 equals 0. This trinomial factors. If it doesn't factor, we just use our quadratic formula. But since it's factors, let's go ahead and do that. We're going to have x minus 15 times x minus 1 to equal to 0. Setting each of these factors equal to 0 gives us two possible solutions, x equals 15 or x equals 1. Now I check these two solutions against my restricted values. My restricted values were 5 and 0. My possible solutions are 15 and 1. They're different. They're not the same. So both of these solutions should work. Let's look at another example. Again, we have a fraction on one side, and on the other side we have a combination of two fractions, and we need to have a least common denominator. We also need to make sure that we know what our restrictions are. So let's start with the restrictions. In our restrictions, our denominators can't be 0. And as I look at the denominators equal to 0, it's easiest to write them in factored form. So let's go ahead and write all of our terms with denominators factored. In our first term, the x minus 3 doesn't factor any farther, so we leave it. On the right side of the equal sign, x squared minus 9 factors to x plus 3 and x minus 3. And our last fraction, the x plus 3 in the denominator does not factor. So as I look at my restrictions, anything that makes a denominator equal to 0 is going to be restricted. So in our first fraction, x minus 3 can't equal to 0. So x cannot be 3. On the right side of the equation, we have two factors. We have the x plus 3 and the x minus 3. We've already done the x minus 3, can't be 0. So now the x plus 3 can't equal 0. So x cannot equal negative 3. Our final fraction is another factor of x plus 3. We've already looked at that as a restriction. X can't be negative 3. This also leads us to our least common denominator. Since the denominators are already in factored form, we can look at the factors, and when we build our common denominator, we may need to make sure that each factor of the denominators is represented in the least common denominator. So we need an x minus 3, which is included here as well. We need the x plus 3, which is also included there. So every factor that I see in the denominator is represented in the least common denominator. Now to get our least common denominator, what we're going to do is we're going to get each one with a common denominator. Our first fraction, 6 divided by x minus 3. This denominator needs the factor x plus 3. So I'm going to multiply numerator and denominator by x plus 3. On the other side of the equal sign, our first fraction, 8x squared over x plus 3 times x minus 3. The denominator is already the common denominator. We don't need to change it. Our last term, 4x divided by x plus 3. It has the factor x plus 3. It needs the factor x minus 3. So x minus 3 times the denominator and the numerator. Now again, since I have the common denominator, all I need to check now is to make sure that the numerators add up. That 6 times x plus quantity x plus 3 equals 8x squared minus 4x times x minus 3. Again, it's going to be a quadratic equation, so let's distribute and get one side equal to 0. So we have 6x plus 18 equals 8x squared minus 4x squared plus 12x. Combining the x squared terms, we have 6x plus 18 equals 4x squared plus 12x. So as we continue, when we subtract 6x and 18 from both sides of the equation, we get 0 equals 4x squared plus 6x minus 18 equal to 0. Now, we can solve this. We see each term here is even, so we can divide both sides by 2. So we get 0 equals 2x squared plus 3x minus 9. This will also factors to 2x minus 3 and x plus 3. Setting each factor equal to 0, we get 2x minus 3 equals 0, which gives us x equals to 3 halves. Setting x plus 3 equal to 0, we get x equals negative 3. Now, checking these solutions against our restrictions, x can't be 3 or x can't be negative 3, so the solution x equals negative 3 is thrown out, and our only solution is x equals 3 halves. Now, some proportions are easier to solve by getting the common denominator instead of cross-multiplying, especially if the rational expressions have a common factor in their denominator. So if I were to multiply by cross-multiplication, I would be doing 3x times an x squared term, which would give me a 3x cubed. A cubic equation is much harder to solve than a quadratic equation. So let's go ahead and factor the denominators of these fractions and see what we can do with that. X squared minus 6x plus 9 factors into the two identical factors of x minus 3 times x minus 3. On the other side of the equation, I have 3x times x minus 3. Now that I've factored the denominators, I'm going to write down what the restrictions are. So the restrictions, x minus 3 can't be 0, so x can't be 3. And on the other side of the equal sign, I have the new factor x, so x can't be 0. Now, before I start solving that, notice that the fraction on the right-hand side could actually be simplified. So let's go ahead and simplify this fraction by reducing the x's. So I have 3 divided by x minus 3. And on the left side, keeping it the same, 9 divided by x minus 3 times x minus 3. Okay? Now, let's go ahead then and find the least common denominator, because these two still have a common factor. So our least common denominator would be both factors of x minus 3. This denominator is entirely enclosed in the least common denominator. So our left side does not need to be changed. Our right side needs a second factor of x minus 3. So let's multiply denominator and numerator by x minus 3. Now, once I have the denominators equal, the numerators must be equal. So 9 must equal 3 times the quantity x minus 3. Distributing gives us 9 equals 3x minus 9. This is simply a linear equation. So solve directly for x by adding 9 to both sides and dividing by 3. So we get a single solution, x equals 6. Check it against our restrictions of 3 and 0. X equals 6 is not one of those restricted values, so our solution is x equals 6. Okay, let's move on to an application of rational equations. So far this year, Michaela has taken 5 algebra tests. She wants to know what score she will need on the next test so that her overall test average is 88%, and her current average is 86%. On a new average of 88% with a current average of 86%. Well, right now, her average is 86%, and she's taken 5 tests. So her total on the 5 tests that she's taken is going to be 5 times 86. And 5 times 86 is 430. So that's her total on the 5 tests that she's already taken. Her new average is going to equal her total on all 6 tests divided by 6, the number of tests that she's taken at that time. Okay? And we want to know what her score will be on her next test. So let's say that x is her score on the 6th test. Okay? So we know we're looking for x, we're looking for the score on the 6th test. The total on the 5 tests that she's already taken would be 5 times the average that she has, or a total of 430. So let's put in the values that we know now and see what equation we have. Her overall average is 88. We want an overall average of 88%, so her new average has to be 88. Our total on the 6 tests would be the 430 points she already has, plus x, her score on the new test, all divided by 6. So we can solve this equation by multiplying both sides of the equation by 6. So 88 times 6 is 528 equals 430 plus x. Subtracting 430 from both sides, we get x is equal to 98. Michaela would need a 98% on her next test to have an average overall of 88%. And that's solving rational equations.